Let's talk about our new Syvecs OEX module. The OEX module is an OEM ECU expander, and it's designed to incorporate with your original ECU applications. The OEX was born from conversations that we had after releasing the WMI module. Many dealers reached out to us and said, can the WMI module do sequential fuel injection? Now, to accurately do fuel injection sequentially, you need to really have a good idea of where your engine is. So we needed to have the ability to be able to decode crank and cam patterns and accurately position where the engine is. The crank and cam inputs are now available to be connected to an OEX, as well as a whole other range of sensors. With 20 inputs available on the OEX, you can add as many sensors as you need, really. And 20 outputs allows you to control up to 12 injectors sequentially. That brings in a whole range of cars that the OEX can cater for. The crank and cam setup can be unique, or it can be specified for a specific platform. We can cater for all. And internal and external fuel calculations allow you to really hone in what you want from the OEX. What I mean by that is, for example, if you've got a Toyota Supra and you need some additional fuel, you can integrate with the Ecotech system to allow it to basically pick up an external fuel target and allow our OEX module to accurately provide that fuel needed. Now we go above and beyond on that because you've got the ability to be able to adjust your angular base of the injection, whether it be start angle or end angle, and we've also got the ability to be able to monitor that fuel that's being provided and feed that back to the original ECU. Then you've got the internal calculation type. The internal calculation type is for systems where they haven't got the original ECU level of structure to be able to send out custom CAN bus interface messages. And what that basically means is you can feed in data into the OEX from a manifold pressure, a mass airflow sensor, and actually calculate the desired amount of fuel that you need internally. Now, fuel multipliers are available, corrections are available, and a whole other host of safety systems are available to ensure that the fuel delivered via the OEX is accurate and safe. Now, how do we know that? So what we've got is 2 additional sensors that are really unique for this application, and those are 2 NTK wideband sensor inputs. These sensors can go in your exhaust system of your car and be able to monitor the air-fuel ratio that's being provided by your engine. With that in mind, we can then pick up the target air-fuel ratio that is coming from the original ECU via CAN or via an OBD2 source and feed that into the OEX. When we get that data, it allows us then to be able to provide additional fuel based on that, which is really unique because in the event that it does go about its range, we can then invoke a limp for the lean lambda. Now, not only are you able to control the additional injectors, you've also got a flex fuel system that ties in with that. So you can add an ethanol content sensor. And in the event that you've got some ethanol in your fuel tank, the system will calculate that and allow you to add additional fuel to suit. This is really cool because not only does that allow you to cater then for multiple ranges of fuel types, you can also then link that into our wastegate control strategy, water injection strategy, nitrous control strategy, and many custom systems on the OEX. So what is unique about the OEX? Well, the OEX also has 4 digital DAC outputs, and what these do is they allow you to pick up data from your application and send it out in a voltage. These are really useful because you can manipulate values going to your original ECU to not only gain, say, more power by lying to the factory ECU that your boost is less and it increases the boost internally to make more power, but you can also do it from a great way of protecting your engine. And what I mean by that is that if the OEX detects a limp for, say, a fuel pressure drop, a lean lambda, not control, you can actually then tee into your, say, pedal position sensor, feed that into an input of the OEX, and then use your DAC output to go back to the original ECU. Now, it basically can do the same as what the original pedal sensor is doing, but in the event of a limp, you can put a multiplier on that value, or you can set it to like 5%. And what that does is it closes the throttle of your original ECU to ensure that you don't do any damage. This is really useful because the OEX has 2 onboard knock sensors. These knock sensors allow you to tee into the original knock sensors on the car or fit your own knock sensors and have our widely renowned known knock control system on your car. How does it work? Well, in the event that you've basically got a knock event, which is structured from looking at a set frequency, basically your integrated time consent, and the values that you set in your OEX, to accurately monitor individually based on cylinder what your knock values are. You can then plot a knock event detection level, and in the event that the knock passes that detection level, an event occurs. Now in the first event, you can decide what you want to do with that. You can first of all just ignore it or say that you allow a certain amount of knocks before you do something. But when the knock control does become active with the Syvecs, most people know that as starting to pull ignition timing and then applying fuel cuts, which is not possible with an OEX because you're basically on top of the original engine ECU. So what we do with that is we take that data and allow you to adjust your fuel target, for example. You can richen it up, add additional fuel. You can then, if you're controlling the boost externally with the OEX, you can then change your boost target. Or you can set a limp mode to be able to set an OEM ECU check light on the dash or set a limp system warning to your external gauge or to the factory ECU. This not only then provides a safe and accurate way of getting additional fuel into your engine, but safely monitor to ensure that in the event of something going untoward, that it's protected. Our water injection strategy from our WMI module is also incorporated in the OEX, and that picks up the level sensor, flow sensor, pressure system to be able to not only deliver additional water injection system values, but actually do something with that safely as well. And that's the key thing that I'm wanting to reiterate here is the word safety. Because gaining power, generally speaking, is quite easy, but doing it accurately and safely is important. You want to make sure that you protect your investment of what you're actually doing with the car and not just take it somewhere and put it into pieces in seconds.
Another area of the OEX to talk about, which is really powerful, is the traction control system. Now, some people might question why you have a traction control system on an OEM ECU expander module, but there's actually good reason for that. And that's because when you start increasing the torque levels of your OEM ECU and applications, the models internally for that start to go out the window. So our traction control system allows you to basically be able to pick up all of the wheel speed sensors and a GPS sensor for the wheel speeds, lateral G, longitudinal G, etc. And you can use the Syvecs 100 Hz GPS module for that. And then from that, you can actually accurately detect any characteristics of wheel spin versus yaw or G sensors. The traction control system that is present in our S7 ECUs and that we've merged over into the OEX. And as you can see here at the bottom, where we've got some wheel spin present between the driven and vehicle speed, where the rear speeds are actually at this moment in time increasing above the front speeds, above the front speeds, we've got a wheel speed present. Now, based on a slip target that you would set, as you adjust that slip target, you can see that your slip error changes and your torque. Now, a really useful feature of this is this torque can actually be incorporated into other strategies on the OEX. For example, you can actually pull this into the wastegate control system, so you can actually start to reduce your wastegate target in the event that basically you are seeing slip. You can also feed this out on the CAN bus. So in the CAN bus system of the actual OEX, you can go out and you can transmit to basically send out the TC torque value. And what that allows you to do then is feed that over CAN back to the original ECU and have a custom map inside the original ECU to reduce the torque that way. So it's a really useful and powerful thing.
The OEX caters for many platforms. It's not just designed for one platform. We allow you to fully enter in your engine configuration setup, your crank and cam setup to suit nearly any engine that's out there. This adds real flexibility to ensure that basically not only is it a one product application, you can install it on anything. The 4 DAC outputs also need to be expanded on, because not only are they good with the limp mode to be able to say, as I talked about earlier, closing the throttle for example on the pedal position, it's actually really useful for, say, certain people that have got a newer application car. Let's say you've got a brand new car, there's no OEM ECU platform for it, there's no aftermarket ECU for it, you want to be able to get a bit more power. Well, the DAC outputs are great for that, because what you can do is you can manipulate the values of the manifold pressure, mass airflow values into your original ECU to increase your boost or ignition timing. But on top of that, as I've said, you can then control the additional injectors. If you start needing additional fueling to match the airflow requirements that you provide, the OEX can do that. The OEX has an external USB data logging. By simply plugging in a USB-C memory stick into the OEX, it automatically detects that and adds a log event system. What that does is, based on your logging parameters inside of the OEX, it then states when the logging should start and allows it to log indefinitely to the size of the memory of your USB stick. This is now really useful because it makes it easy for end users to be able to take their platform out in the event something's not right, unplug the USB stick and send that file to your calibrator. The calibrator can then use the SCAL software to decode that data and convert it into an SD file, which our SView logging analytics software can use to be able to do a whole host of unique things. The OEX has 20 inputs, and these 20 inputs can be used for a whole numerous range of sensors that can be fed into the OEX to feed into strategies and also feed back to your original ECU. You've got flex fuel input support, cranking cam obviously, multiple cam sensors to be able to pick up your angles. You've got air temp, water temp, fuel pressure, knock, you name it, we've tried to add it to basically allow you to get as much data into your OEX. Like our tiny dash and water injection module system, the OEX has onboard CAN bus. And with that, where we've got a whole host of CAN bus data bus information, we've actually incorporated that into the OEX as well. What that means is you can pre-select a certain platform from the array of list of cars that we offer, and that will automatically go off and grab some of the CAN information that's readily available. Whether you've got a Nissan GTR, a new Porsche 992, you've got a new Audi. Most of that data we've already grabbed, and with the addition of now a CANFD chip on the OEX, it allows us to support even newer types of cars, to allow the hardest types of ECUs that were not able to be tuned or cracked or aftermarket ECUs available for, now provide a solution to be able to get additional power from. And this is really useful. The CAN system also has the ability to pick up the OBD2 data. So you can connect the OEX to your factory CAN system and then grab data from the OBD2 system of the factory ECU. You can grab your lambda, the manifold pressure, air temperature, water temperature, anything that yours available on a data monitoring list on the OBD2 for your car, we can then incorporate and grab that into the OEX. And that makes the installation really simple, because it doesn't mean you need to start cutting into loads of wires on the car to get data into the OEX. You can actually use the sensors and systems that are already available from the original ECU and feed that into the OEX. The main important sensors that we really just need is a cranking cam to accurately know the engine position, and then from that we can then deliver fuel sequentially and accurately at any given angle to what your engine desires.
The wastegate control strategy on the OEX is also really powerful. We've basically pulled in the control strategies that we have in our normal ECUs and incorporated that into the OEX, but we've added some additional functions on top of that, where it's an internal and external control option. The internal option allows you to basically calculate your targets and duty cycles all internally from the strategy in the OEX. But if you choose the external option, basically that allows you to actually send in a CAN message to fulfill the wastegate final duty external variable, which can be set up in the data streams generic CAN receive. And from that, you can actually then have it so that the wastegate control solenoid outputs are driven based on this target of duty from an external source. The other option, if you were to set this back to internal, you do have the option under the targeting systems to allow an external target. And what that means is that the item WG map target external If that was filled with a value from an external CAN source or from an OEM ECU, you can then use that external target and basically fulfill the target transition table that links into the full OEX wastegate control to basically then control your wastegates from the target of an external source. So it's really powerful.